All right, welcome to Friday. Hopefully, you're getting into the swing of things. So, last night's homework, go ahead and get it out. So, remember, I changed the instructions to I wanted you to round to the nearest hundredth. So, you had to do that technique by hand, take it out to the thousands place, and then round to the nearest hundredth. So, let's see. Question number two, the answer is 3.61. 3.61. Question number four, the answer is 4.84. 4.8. Now, if you put 4.80, same answer. Question number six, 2.24. 2.24. Remember, all these are approximate answers. 2.24. Number eight is 6.48. 6.48. Number 10, 8.66. 8.66. All right, number 12. Number 12 is 8.31. 8.31. That's for number 12. Number 14, 2.74. 2.74. Number 16. Number 16 is, let's see, let me find the answer. Oh, there it is. 2.63. 2.63. All right, two more left. Number 18 is 2.14. 2.14. And the last one, 1.26. 1.26. Okay, count up how many you got wrong, put that on the Google Forms, and then let's continue. All right, so here's our calendar. Next week is a repeat of this, except we'll have classes Monday, Wednesday, Friday. Remember, if you need help, specific help, email me, and I'll give you that help on Tuesdays and Thursdays. You can email me at any point, including the weekends, and I'll respond. And the next thing we have is a quiz in 2 weeks. All right, here's your homework tonight. Okay. Yeah, a really important lesson. You're going to be using what I'm going to teach you today between now and whatever the last math course you ever take in your life is. Pythagorean theorem is used in all branches of mathematics, and yeah, it's a pretty cool thing. I'm going to spend 2 days on this. We'll do three things today. Some of this will make sense after we do it. Some of it shouldn't make sense right now. So let's talk about this thing called a Pythagorean theorem. Well, there's two words there. Some of you may be familiar with either one or maybe even both of those. But for those of you that are not familiar with either one of these two words, well, let's look at the second word, theorem. Theorem. In math, we call theorem a mathematical rule. So this is going to be a rule. When you get to high school, in the course called geometry, we will start proving these rules to you. Right now, you just have to take our word for it and assume that we know what we're doing, and we do. But geometry is the course where we actually prove theorems. Now you're just going to accept these as a fact. And the first word is Pythagorean. Well, Pythagorean is named after a guy, Pythagoras. He was a Greek mathematician. There's a bust of him. And his theorem deals, or his mathematical rule deals with right triangles. Right triangles. So let's review our knowledge of right triangles. And we've talked about right triangles a couple times this year already. So put this in your notes. Let's label the parts of a right triangle. Parts of a right triangle. Well, first off, how do I know it's a right triangle? All triangles have three interior angles, and for a right triangle, one of the angles is 90 degrees, and it's indicated by that little square shown at the corner. Why do they choose a square? Remember, a square has four right angles. Okay, so this is a right triangle. We call the two sides of the triangle that are attached to the right, or that form a right angle, we call them the legs of the triangle. Now, this is only for right triangles. We don't call the sides of other triangles legs. So these are called the legs of the triangle, and we call the third side, the side that is opposite. Well, let's write this down first. Leg. Sides that form the right angle. I say that they touch the right angle. Well, in fact, they make that right angle. Okay, so the side that's opposite the right angle, the third side, we're going to call this the hypotenuse. Hypotenuse. Okay, that is definition of hypotenuse. It's the side opposite the right angle. So when you see a right triangle, your eye naturally moves to where the right angle is. That's how you identify it as a right triangle. What you need to do now is be able to identify the legs and the hypotenuse of those right triangles. So the legs are the ones that touch the little square, or they form the right angle, and the hypotenuse is the side that is opposite. Now, right triangles can be, I mean, typically this is how a right triangle is drawn, but remember that there's many different ways. So there are three triangles right there. Three triangles right there. And I want you to pause the video after I give you the instructions. I want you to pause the video and I want you to identify the legs and the hypotenuse of each one of these triangles. So I got a blue, red, and a yellow one. So identify the legs and the hypotenuse of each one of these triangles. Okay, so for the blue one, first off, the side that's opposite the right angle, so I find the little square, I look for the side that's opposite it, that's the hypotenuse, which makes the other two sides the legs. We're going to do this each and every time. Look at the red one. The side that is opposite the right angle is called the hypotenuse. The other two sides are called the legs. And lastly, on the yellow one, the side that is opposite the right angle is called the hypotenuse, and the other two sides are called the legs. And you're like, well, that seems like a lot of work. We got a little bit out of it. You know, what good is being able to identify the hypotenuse and the leg? Well, the Pythagorean theorem says something about the legs and the hypotenuse of right triangles. All right, so here is literally the Pythagorean theorem. The Pythagorean theorem says the following. It says, if you have a right triangle and the hypotenuse will be called the letter C. So we're going to call the distance of the hypotenuse the letter C. And one of the legs is going to be called A, one of the other legs is called B. Not very creative there, but that's what we call them. So we call the hypotenuse C, and we call the two legs B and A. Now notice, for most, unless an isosceles right triangle, for most right triangles, A and B will not be the same distance. And obviously C is not the same distance. So we're going to call A and B the legs. We're going to call C the hypotenuse. Now this is what Pythagoras said, and this is what he figured out as well too. He figured out, and many cultures figured this out as well too. Pythagoras gets credit for it because he was probably the first one to actually write this down. Therefore, he gets credit. But most societies were able to calculate and figure this one out. He said the following. He said that if you square both legs and then add them together, that will equal the hypotenuse squared. I'll say that again. If you square each one of the legs, it means you square A, and then you square B, and then you add those sums together, right? If you add those two values together, the square of A and the square of B together, that you get the square of C. You get the square of C, and that is the Pythagorean theorem. What the? Yeah, there should be angels singing. Oh, this one's a really... All right, one key note here, make sure you write this all down. One key note is that C is always, 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 always the hypotenuse. You know, you can't just pick one side and say that the other two sides squared added together equals the third side squared. It's only the hypotenuse squared that is equal to the sum of the squares of the other two sides, or the legs in this case, okay? If you need to rewind the video and hear that again, make sure you got that one locked in your brain. The hypotenuse squared is equal to the sum of the squares of the two legs. Okay. Now, obviously, you know, if we were in high school, I would, and I will, if I have you for geometry, I will prove this to you. I'm going to show you a quick visual proof to convince you that the sum of the squares of the two legs is equal to the square of the hypotenuse. So watch the video. So what just happened there? So what just happened there is you have a right triangle, and we took each one of the legs and we made a square out of that distance. So you got a small square, you got a medium square. You took the two sides of the two legs of the right triangle, and you made squares out of that, and they filled them with water, blue water in this case. And they took the hypotenuse and they took the distance of the side of the hypotenuse and made a square out of that. And they're showing you that in this case the volume, but remember we're talking about area right here. And so that's supposed to convince you that the sum of the squares of the two sides of the two legs of a right triangle equals the square of the third side, the hypotenuse. Okay. All right. So that's the Pythagorean theorem. So Pythagorean theorem is you have right triangle with legs A, B, and C is the hypotenuse. Then a squared plus b squared equals c squared. So how do you use this? Well, they're going to give you a triangle, and it will be a right triangle. You'll know it's all right. Let's do another one. So it's a right triangle. Check it out. It's got a little square on it. What we're missing is the hypotenuse. Notice each time I'm drawing this little arrow pointing to it. We don't have to do that always, but at least to get you in the habit of identifying which one is the hypotenuse, it's a good idea. So let's see. We don't know what C is. So we take the two values, A and B. We square each one separately. 5 squared is 25. 6 squared is 36. We add those two together. 25 and 36 is 61. Yeah. And then to get rid of the squaring, we take a square root of both sides. Now, 61 is not a perfect square, so drum roll please. Yes, tonight you may use your calculators. All right. So the square root of 6, please don't use them for perfect squares. You should have those memorized. Square root of 61, let's see, without a calculator, that's between let's see, 64 and 49. It's really close to 64, so I'm going to guess it's, I don't know, 7.8, 7.9. With the calculator, you can find out it's 7.8. Let me flip real quickly to the homework. Let's see what it says. It says for homework, it does not say, oh yeah, it says round answers to the nearest hundredth. So I round mine to the nearest tenth. Okay, let's do another one. Go ahead and pause the video if you know what you're doing, get to the answer. If not, follow along step by step. Okay, we are missing the hypotenuse, so we're solving for C. We take the two values, we plug them in. Remember, you can't do 6 plus 8. You got to do 6 squared, and then you got to do 8 squared, and then add them together. 6 squared is 36. 8 squared is 64. 36 and 64 is 100. I know that one. The square root of 100 is 10. So C is equal to 10. You getting the hang of this? All right, for those of you that need to see this again, back up, watch the 3 examples again, and before you move on to the next box. All right, there's 2 problems there. Go ahead and solve both of those. Those are questions, I think 2 and 3 on the Google Forms. So go ahead and answer both of those. And it is a multiple choice on the Google Forms. How'd you do? All right, so the first one, 3 squared is 9, 4 squared is 16, 9, 16, 25, squared 25 is 5. So we get an answer that C is equal to 5. Second one, 12 squared is 144, 5 squared is 25, 144 and 25, 144 is 169, and the square root of 169 is 13. Makes sense? All right, notice on each of these 5 examples we just did, we were solving for the hypotenuse. Well, what would happen if you know the hypotenuse? In other words, what you're missing is one of the legs. So let's do one of those. Check it out. I know the hypotenuse, the side that's opposite the right angle is 13. What I'm missing is A or B. I'm just going to call that one B. Okay? And remember, it doesn't matter which one you call A or B. All right, so just the algebra is slightly different. We still do it the same way. A is 12, so it's 12 squared plus B squared equals 13 squared. Notice it's similar to the previous one. 12 squared is 144. 13 squared is 169. Now, to solve this algebraically, we're not going to take the square root of both sides first. We're going to get rid of that 144. Makes sense? Right? Get rid of addition and subtraction first if you can. So we get rid of the 144 by subtraction. 169 minus 144 is 25. And then the last step is to take the square root of both sides. The square root of 25 is 5. Does anybody notice a pattern? Yeah, math teachers love 2 special triangles. The 3, 4, 5 and the 5, 12, 13. You're going to see this over and over and over again when we do with right triangles. It actually has a name to it. We'll talk about it, I believe, tomorrow. All right, let's do another one. Let's see. The side opposite the right angle is the hypotenuse. So I have the hypotenuse. I'm missing one of the legs. And it doesn't matter whether you say it's A or B. I'm going to call it A this time. So let's see. A squared plus 10 squared equals 26 squared. Let's see. 26 squared. That's not one of the ones we have memorized, right? But you can use a calculator tonight. So 676. And obviously 10 squared is 100. Next step. Yep, subtract 100 from both sides. That gives me 576. And it turns out the square root of 576 is 24. Got it? All right. For those of you who need to rewatch that, back up, watch those two examples one more time. And if you're ready, move on to the next one. Okay, so these are the next two questions on the Google Forms. So we did 2 solving for the hypotenuse. Now we're doing 2 solving for a leg. So go ahead and answer both of those questions. They are multiple choice, and then play the video to see if you got it right. How'd you do? All right, in the first one, let's see. A squared plus 8 squared equals 10 squared. That would be A squared plus 64 equals 100. Subtract 64 from both sides. It gives me a 36, and the square root of 36 is 6. Second one, final answer is 24. How'd we do? Okay, if you're still having struggling with this, go ahead and rewatch the video for the 3 examples that we just did, or the 2 examples we just did. And if you still need assistance, email me. I can give you more practice problems than you're ever going to want. Okay, hey, we actually only got one thing left. It's really just a day and a quarter lesson, but I didn't want to squeeze all into one day, so we're doing this in 2 days. Okay, so the last new thing is this. All right, let's say that you are, you're given a right triangle and you're actually given the sides like the previous one. So A is 6, B is 8, and C is 10. On the second one, the blue one, A is 24, B is 7, C is 25. Notice which side is always the longest side. And that's correct. And this is only for right triangles. For right triangles, the longest side is always the hypotenuse. It is always the hypotenuse. So the next, or I should say the last thing that we're going to do today is they're going to give you 3 measurements, and you're going to determine whether or not those 3 measurements could actually form a right triangle. Okay, I'll say that again. They're going to give you 3 measurements. Say 4, 5, and 6, and they're going to say, can those sides, the length 4, 5, and 6, be arranged in some way to form a right triangle? Okay. There will be steps in this process. Go ahead and write down these steps. Pause the video. And these steps basically tell you how you determine whether or not 3 sides or 3 given sides can actually form a right triangle. All right, so how does this work? So the question will be, I believe in homework, do these 3 sides or 3 measurements form a right triangle? So here's how it works. They're going to give you 3 measurements. Following the steps, it says, step number 1, you're going to write the base, just the Pythagorean theorem. So the Pythagorean formula says a squared plus b squared equals c squared. We know that if it is a right triangle, then the longest measurement must be the hypotenuse. Well, that means in this particular case that 5 is the hypotenuse, which leaves 3 and 4 as being the 2 legs. So then therefore, it doesn't matter which one you make is A or B. So 3 squared plus 4 squared equals 5 squares. And then basically, the following steps is see if that's true. If it's true, then it's a right triangle. But if it's false, it is not a right triangle. It's either obtuse or it's acute. All right. So let's see, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And yes, it turns out that 9 plus 16 is 25. So this one actually is the left side equals the right side, so therefore the answer is yes. So once again, they're going to give you 3 measurements. You're going to take the longest measurement and make it C. You're going to plug in the other 2 values in for A and B, and you're just going to see if the left side equals the right side of the equation. Make sense? All right, let's do another one. So 8, 12, and 4. 8, 12, and 4. Step number 1, you write Pythagorean theorem or the formula. Now you identify, step 2, you identify the longest side. The longest side is 12. That makes it C. And the other 2 sides are A and B. And it doesn't matter which one you pick for A or B. So let's see if this works. 8 squared is 64. 4 squared is 16. And 12 squared is 144. Does 64 plus 16 equal 144? Heck no. Therefore, if the left side doesn't equal the right side, then does not form a right triangle. It does not form a right triangle. All right, do one together. All right, so let's see. They give you three measurements, 12, 10, and 20. You write the formula. You identify the longest side. The longest side here is 20. We plug the other two numbers in for A and B. Pause the video, rewind it if I'm talking too fast. 12 squared is 144, 10 squared is 100, 20 squared is 400. Does 144 plus 100 equal 400? Heck no. Therefore, this is not a right triangle, not a right triangle. So if the left side equals the right side, the answer is yes, it is a right triangle. All right, if you need to see those three examples again, go ahead and rewind. If not, go ahead and do these, the last two questions on the Google form. The answer is just going to be yes or no. Yes, it is a right triangle, or no, it is not a right triangle. So do those two, please. How'd you do? Well, it turns out that on the first one, the one on the left there, that 9 squared plus 12 squared does equal 15 squared. You get 225. So that one is a yes. And the old math teacher dictate says if one is yes, then the other one must be no. Let's see if that's true. Let's see, the hypotenuse for the second one, the one on the right there, would be 20. So does 12 squared plus 15 squared equal 20 squared? And the answer is no. The answer is no. Okay. You may or may not know this, but the Pythagorean theorem or the Pythagorean formula is used quite a lot. In fact, it's in movies. We even had a president, I believe it's President Garfield, actually wrote a proof of the Pythagorean theorem. Here's a movie that has Pythagorean theorem in it. It's Wizard of Oz. It's one of the last lines of the movie.
Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
PhD?
That's Doctor of Thinkology.
Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy! Rapture! I've got a brain! How can I ever thank you enough?
Well, you can't.
Yeah, well, the irony there is that he actually doesn't specifically say the Pythagorean theorem. So there are isosceles right triangles, and it is true for that, but he says of an isosceles triangle. So while it's true for right isosceles triangles, it's not true for all isosceles triangles, but it is true for all right triangles. I guess the irony there is that he's supposed to get a brain, and he ends up saying something that is not actually true. So we're not sure whether or not that was an intentional or that was literally a math mistake. An interesting thing. All right, so we did those three things today. There's your homework. You guys have a great weekend, and I will see you guys on Monday.
Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
PhD?
That's Doctor of Thinkology.
Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy! Rapture! I've got a brain! How can I ever thank you enough?
Well, you can't.
Really important one because we use it so often in mathematics. Okay.